Okay, so now we shall explain what do you mean by independent events? What do we mean by independent events? So uh, if the events if like E and F, if E and F are two events which are also associated with a sample space S of a random experiment, and which are such that such that the probability of happening of the event E is is not affected. It means mm, it means if E and F are two events such that the occurrence of any one of the events, any one of them does not affect the occurrence of the other event, like the occurrence of the other event, then the events E and F are called independent events. The events E and F are called independent independent events. Independent events. Okay. So the rule is that if E and F are two independent events, E and F are two independent events, then we have that the probability of happening of the event F, given that the event E has happened, that is equal to the probability of the event F, provided that the probability of happening of the event E is not equal to 0. And also the probability of happening of the event E given that F has happened, that is equals to same as the probability of the event E, provided that the probability of the happening of the event F is not equal to 0. So therefore, if we have to find, so the rule is that if E and F are independent, E and F are independent events, then the probability of the simultaneous occurrence of the events E and F, the probability of the simultaneous occurrence of the events E and F is given as the probability of E intersection F, that will be equal to the probability of happening of the event E times the probability of happening of the event F given that E has happened. So if they are independent, then the probability of F given E, that will be same as P of F. So this can be written as P of E times P of F, simply. Okay. So hence we can say that if E and F, if E and F are independent events, are independent, then we can have P of E intersection F will be, it means the probability of the simultaneous occurrence of the events E and F, that will be equal to the probability of the happening of the event E times the probability of happening of the event F. And if it is not true, means if we can say that the probability of the event E intersection F is not equal to the probability of E times the probability of F, then we will say that the events E and F are not independent, means they are dependent. Then it means the events, it means that the events E and F are dependent events. E and F are dependent events. The events E and F are dependent. It means they are not independent. They are not independent. Independent. Okay. And then sometimes there is a confusion with the terms mutually exclusive. There is a confusion with the terms mutually exclusive events, and the term independent events. Independent events. So what do we mean by independent events and what do we mean by mutually exclusive events? So mutually exclusive events, it means that if the events E and F are disjoint, E and F are disjoint sets, means there should be disjoint events. Means there should be disjoint events, means what? That they should not have any common outcome. It means E intersection F that should be equal to 5. It means when they do not have any common outcome. Then the event sets E and F will be called as mutually exclusive events. And independent events, it means that it is not and in case of independent events, if E and F are independent events, then E and F may not be disjoint sets. They may not be disjoint. They may not be disjoint events. It means it is not necessary. It is not necessary that E intersection F should be 5. It means that E and E intersection F will not be equal to 5. It means it means they may have one common outcome. Means then E and F, the events E and F may have a common outcome if they are independent. So if E and F are mutually exclusive, then we should have the probability of happening of the event E intersection F, that will be simply 0. But if E and F are independent events, then it is not necessary that P of E and F will be 0, and then P of E intersection F will be P of E times P of F. Okay. So it means these two terms are not same. They do not have the same meaning. These two terms, they are not the same. Okay. Then if we have 3 events, suppose if we have 3 events, let's say if the event sets, if the events A, B, and C, the events A, B, and C are mutually independent, are mutually independent events, then we should have that the probability of happening of the event A intersection B, that will be equal to P of A, means the probability of happening of the event A times P of B, and the probability of happening of the event A intersection C, that will be probability of happening of the event A times probability of happening of the event C, and then probability of happening of B intersection C, that will be probability of B times probability of C, and the probability of happening of the event A intersection B intersection C. It means the probability uh, of the simultaneous occurrence of the events A, B, C, that will be equal to P of A times P of B times P of C. So then I will tell that the three events A, B, and C are mutually independent events. So uh, we can explain it by using a suitable example. Um, One example, suppose we have got three coins we are having. So these three coins are tossed simultaneously. Three coins are tossed together, we can say. Then we consider three events. One event E. The event E is defined as three heads or three tails. We should get three heads, means all three heads we should get, or we should get all three tails. So it means the event E is a set which contains the elements which are H, 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 and tail, tail, tail. So all three will be tails once again. And suppose we consider the event F. The event F is defined as at least two heads. At least we should get two heads. So then the event F will contain the elements which are H, 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 and then H, H, T, and H, T, H, and T, H, H. And the event G will be is suppose defined as at most two heads. At most two heads. It means the event G will contain the elements which are at most two heads, means I should get HHT, HTH, then THH, then head, tail, tail, and tail, head, tail. You get tail, tail, head, and we can get tail, tail, tail. So we can get all three tails, or we can get two tails, or we can get one tail. And S, the sample space, S is the sample space which contains all the outcomes of this experiment. So S will be, it will contain all three heads. It will contain HHT, it will contain HTH, it will contain THH, it will contain HTT, it will contain THT, it will contain TTH, and it will contain all three tails. So these are the 8 outcomes it will have. So now here we need to find which of the pairs of the events, like E, F, the events E and F, and if I take, say, the pair of events E and G, and the events F and G, so out of them, which ones are independent? Which ones, which pairs of events, which pairs of events are independent, and which ones are dependent, and which pairs of events are dependent? So that we have to find. Okay, so therefore, so if we have to prove that E and F are independent, then we should prove that P of E intersection F, that should be equal to P of E times P of F. That we have to prove. But we have to check actually. So first we need to find the events E intersection F also. E intersection F, that will be the event which contains the common elements among E and F. So that is only one event, that is HHH. And we need to also find the event which is E intersection G, which contains the outcomes which are common to the events E and G. So that will be only one, that is T, T, T. And we have to find the event that is F intersection G, which contains the outcomes which are common to the events F and G. It means it will contain HHT, and it will contain HTH, and it will contain THH. So these three events. So now we need to find the probability of the event E. So that will be the number of elements in the event E divided by number of elements in the event S. It means the number of outcomes in the sample space. It means all possible outcomes. So number of elements in the event E, that is 2 by 8. So that is 1 by 4. And the probability of the event F, that will be number of elements in the event F divided by number of elements in the sample space S. So that will be 4 by 8, that is 1 by 2. And the probability of happening of the event G, that is, it is equal to number of elements in the event G divided by number of elements in the event S. So that will be number of elements in this one, that is 7. So 7 by 8, that is. So now we need to also find probability of the event E intersection F. That will be number of elements in the event E intersection F divided by number of elements in the event S. So that is intersection F is having one element, so that is 1 by 8. And probability of E intersection G, that will be also equal to number of elements in E intersection G divided by number of elements in S. So that will be also 1 by 8. And we need to also find the probability of the event F intersection G. So that will be the number of elements in the event F intersection G divided by number of elements in the event S. So that will be equal to 3 by 8. So therefore now we need to find the value of P of E times P of F. So P of E we got 1 by 4 times 1 by 2. So that will be 1 by 4 into 1 by 2, that is 1 by 8. So as we can, and then we have to find P of E times P of G also. So P of E is 1 by 4 and P of G is 7 by 8. So that is 7 by 32. And similarly, we have to find P of F times P of G. So that will be P of F, it is 1 by 2 times 7 by 8. So that is 7 by 16. So now here we can see, here we can observe that P of E intersection F, that is coming same as P of E times P of F. That is equals to 1 by 8. So we can say, so the events, so the pair of events, sorry. So the pair of events E and F are independent. They are independent events. And here you can see that P of E intersection G, that is not equal to P of E times P of G. Since why P of E times P of G is coming 7 by 32, but P of E intersection G is coming 1 by 8. So they are not same. So I will tell, so the pair of events E and G are dependent. They are dependent pairs of events. They are dependent events. And similarly, P of F intersection G, that is also not coming same as P of F times P of G. Since why P of F intersection G, that is coming 3 by 8, and P of F times P of G, that is coming 7 by 16. So they are not same. Hence, so we will tell that the pair of events F and G, they are also dependent. Thank you.